Hello, everyone, and thank you for joining our session, Digital Data Center Operations Makes Data Centers More Sustainable. This is the fourth webinar in our Data Center Sustainability series. My name is Rachel Emanuel, and I'm today's moderator. Before we begin, let me highlight some features of this webinar platform. There is a Q&A panel to the right of the slides. During the presentation, you can submit questions at any time by entering them there. Our speaker will address as many as possible at the end of the presentation. You will receive an email later this week with a recording of this presentation and a copy of the presentation material. This five-part series covers sustainability trends and innovative technologies that support reliable data center operations while consciously managing environmental impact. The last session in this series will run 2 weeks from today. You can find the registration link to sign up for the remaining webinar in the reminder email you received for this session. Your speaker today is Rich Ungar, Head of Data Center Automation for the Americas at ABB. Now I will turn it over to Rich.
Okay, thanks, Rochelle. So as described, see if I can advance the slides. Here we go. We're going to talk about sustainability and data center, digital data center operations today. So during this session, I'm going to do a quick introduction to data center automation and digital data center operations, talk about a little bit about what that's all about. And then I'm going to run through a set of scenarios or strategies for control in data centers and how those different strategies can improve sustainability goals. Mostly around energy, but also a little bit about carbon usage, water usage, and of course, cost reduction. And then I'll give a short summary at the end, followed by Q&A. So first off, digital data center operations, what is it? So DDO covers a pretty broad set of products and capabilities within the data center, but all around, operational and management activities. So in this particular presentation, I'm going to focus on a couple of them. Most of the scenarios and strategies deal with our data center automation product, ABB Ability Data Center Automation. I'll also get a little bit into the energy management product. So specifically around data center automation, a little bit of background. So I am part of the ABB Industrial Automation business, and so our team is responsible for controls, monitoring, operations generally for a number of different industries and mission critical businesses, so chemical, power generation, oil and gas, etc. And there are some common themes, common concerns across all of those industries. They all require a high degree of availability for the infrastructure. They all are concerned about efficient operations, cost efficiency, etc. And of course, they all require very secure environments. So data centers are no different, and data center automation is basically industrial controls for data centers. So we define data center automation as control, monitoring, and optimization for your mission critical infrastructure with mechanical, aka BMS, electrical, EPMS, SCADA, and DCIM capabilities in a single industrial solution. So what does that mean? really the focus of data center automations is about contrasting a unified system with the way that data centers are typically built and operated today. So if you look at the way that a typical data center is constructed and then operated today, you still see a lot of these silos built around the different subsystems. So the electrical systems or electrical infrastructure is typically managed by an EPMS, and it's got its own displays and reports and data repositories, etc. The building management system will have its own system managing all of the mechanical cooling equipment, etc. You may have something else if you're looking at the substation. Perhaps you've got battery monitoring. You may have DCIM, which is looking at some more data, maybe coming from the white space. And then a whole host of other ancillary systems, lighting, closed circuit TV, physical security, etc. So all of these, what we call silos, exist with their own infrastructure, their own systems, managing it, monitoring it, reporting on it, generating alarms, etc. And those, building in those siloed systems tends to be, somewhat costly to build, but also very inefficient to operate. So the data center automation philosophy is eliminate the silos, build the data center or support the data center with a consolidated system to be able to manage all of the physical infrastructure within one system. So rather than have silos around electrical and mechanical, you would implement a single system to manage all of the infrastructure into a single data repository, and then have a single set of displays and reports and alarms built on top of that infrastructure. And of course, that gives you tremendous insight into what's happening within the data center at any given time, gives you the ability to manage it much more efficiently. But having all data collected into a single database or a single repository then lets you start to add on sort of more advanced capabilities. So planning and operations management, you get sort of better ability to view performance KPIs, more data from an analytics perspective, and then you can start to do more energy optimizations and other advanced features on top of that single data set. So that's kind of what we're going to talk about a little bit today, is the kinds of things that you can do from the energy optimization and sustainability perspective, having access to that broad range of equipment and data. So learning from other industries is an opportunity. Like I said, we're talking essentially about industrial controls concepts within the data center. And those concepts would be, a single system to manage the facility instead of multiple, robust and secure solutions that you can trust, and controls to manage and optimize operations using either simple or advanced control logic. And that's the sort of focus of today's talk. So we went through and identified basically 5 strategies or 5 philosophies around controlling the data center, and how those different philosophies would then translate into benefits from a sustainability point of view. So the first, the most simple, and frankly the most common strategy is what we call open loop. Again, sort of borrowing from the industrial control space. So open loop basically means monitoring and then manually taking action. Right? So monitoring how the data center is behaving, looking for problem areas, for example, hotspots and load imbalances, things like that. But the benefits of being able to have access to all that information are still pretty substantial. You can identify areas of concern, so poor airflow, containment issues, identify, old or inefficient servers if you're monitoring the power consumption. Also identifying, transient conditions. If you have good, real-time visibility into the performance of your data center, you can identify things that you might not realize are going on because they don't persist. I mean, maybe they happen at a particular time of day or whatever. So, having that system collecting data can provide, better insight. And of course, with access to data, there are, ways that you could change behaviors, introduce new business models, and those can also drive sustainability targets. So in general, the idea is you're driving down energy consumption, and that then has impact on reduced carbon footprint and, of course, reduced cost. So, just basic examples. We released an article a couple of weeks ago with some stats from one of our customers. This is a small data center in Ohio, Lakeland Community College. They had put our system in a few years ago and saw pretty substantial energy savings opportunities right off the bat. So, just by looking at the temperature profile of their data center, and they were able to identify airflow issues. Real-time visualization helped them, identify transient problems, and better access to data meant that it was easier to calculate the ROI for investment. So they were actually able to more easily justify the additional investment that was required to address the problems that they found, because they had the ability to collect and report both on the problems, but also the improvement as they address the problems. So, they figured they saved a substantial amount on their energy bill. 53% was the number they said, and that came from a number of different initiatives that they took over time. But even in a small data center, that was pretty substantial. And on top of that, they also said that the visibility gave them improved uptime, just because they could identify problems before they led to any kind of outage. I put the link to the use case in the slide, so when you get the slides, you can read up on that. It's also on our website. So other examples, just from the sort of open loop approach, looking at the way that the IT assets are used. So implementing a DCIM solution, for example, on top of the data center automation system can help address, concerns where you see that, there are hotspots, which could mean that the servers are too densely spaced, or, if the servers are too loosely spaced, maybe you have some inefficiencies. It's inefficient to cool that way. You can look at loading. So maybe you've got too many servers on a circuit, or perhaps you've not properly distributed the A and B side power. So all of those things are identified easily through just monitoring. And I made the point earlier about changing business models. So interesting. I was reading an article about how just implementing tenant or IT chargeback can help drive down energy consumption. I mean, pushing costs back to the consumers or the users of the IT infrastructure can help reduce energy consumption, because they see the direct impact on their individual bottom lines. So with the data, you can use that data in a number of different ways, including changing the business model. So moving along with the control strategies, the second control strategy we've defined as closed loop. So again, a little bit more sophisticated from a controls perspective. Basically have the system automatically manage some element of the infrastructure. So it ensures that operating conditions are maintained automatically. You can program the algorithms that are used to control it to optimize either around the temperature set point, or even just looking for ways to optimize energy or water consumption. That logic can be either simple with the PID type control, or it can be complex, machine learning, model predictive control. All of these options are available and used. The benefits of a closed loop control strategy are the system can adjust to changing load, environmental conditions, and in the meantime, keeping your costs minimized. So depending on how it's being used, you can drive down energy usage. You can improve your water consumption if you're using some kind of closed loop strategy around a chiller, let's say. And all of that stuff can, again, reduce the carbon footprint and bring your costs down. And you tend to see control. I mean, every data center has some closed loop control somewhere, even if it's just within the crack, where it's maintaining a set point temperature based on the inlet temperature or at the return air temperature. But you can have closed loop control at many different levels. So generally using closed loop control for cooling applications. You can actively control to lower energy or water usage. It could be based on a single unit, like I mentioned, a single crack or craw. Could be used across a number of units in an area. So if you're coordinating the control of the number of cooling elements within a single data hall, for example, or it might be across the whole data center. Maybe you're optimizing use of shared equipment across the whole data center. There are a number of ways that you can implement it. But what I show is a fairly standard control loop design with a controller managing the cooling equipment. The cooling equipment in turn generates the cold air to the servers, and the server, of course, generates hot air, which is then measured from a temperature, pressure, humidity perspective and fed back into the controller, and adjustments are made with this disturbance being the environment, outside environment, inside air conditions, and then the load on the servers, which would impact their performance. And the control then could be, as I mentioned, it could be simple or complex depending on what you're trying to do, and it can incorporate lots of different elements. If you want to factor in weather forecasts or what have you, and you can also feed back more than just temperature information. So one example I give when we talk about a fully unified system is look at the energy consumed by the servers as well, right? I mean that can be fed back into the control, and then you can have sort of more complicated control logic within the controller that might try and factor in total consumption by the servers to try and optimize based around the energy consumption. So as everybody knows, you try to manage the server inlet temperature according to the ASHRAE standards. People try to stay within, one of the blue boxes in the psychometric chart to keep things behaving properly. But once you move outside of those areas and start to increase the temperature, servers have different ways of responding. So sometimes as the inlet temperature goes up, they start to spin their internal cooling fans faster, and those fans draw a lot of power. So even though you might be saving energy overall, or saving energy from a cooling system perspective, your actual power consumption or critical power consumption within IT is going up. So if you can also measure that as part of the same system, you could potentially feed that back into your controller and make sure that you're not setting the temperature set point too high. Again, that's a example that is only possible to implement if you do have that unified system. But it gives you an idea of how you could potentially optimize data hall cooling using sort of all the information that's available to find the warmest temperature within reasonable constraints where minimum power is consumed. And there are some well-known, notable examples where some pretty sophisticated control logic is used to drive the efficiency of the overall cooling system down. I think most people are aware of the Google DeepMind test, where they used their machine learning algorithms and took a very sort of control theory based philosophy for managing their cooling, and saw substantial savings in cooling power, something like 40%. So there are definitely significant benefits to be had by looking at all of the data that's available within the data center and using it to control whether you're using something as sophisticated as this or not. The third strategy is not so much a control strategy, but it's a design strategy for the data center. And I call it, data center as part of an extended infrastructure. So, and this would obviously depend a lot on whether you have access to, some of the extended infrastructure options. But, taking advantage of site or regional opportunities to, for example, redirect waste heat, use on-site power generation capabilities to reduce utility demand, et cetera. And so the benefits there are primarily around cost savings or net reduction of demand on the grid. So, the cost goes down, and overall the system energy consumption goes down, carbon footprint, again, goes down as a result. And, there are some examples of this kind of stuff being used. Again, we've got a reference case for a data center in Sweden owned by Ericsson, where they use a full data center automation solution to manage their building based around a multi-stage chilled water system to manage power. So they've got automated load shedding and restoration capabilities, and then total power visibility. And they use all of that information and the controls that are associated with all of it to interface to the district heating system. So they provide heat and hot water to local residents. This is tied into the system. And that has a significant impact on their energy total energy sustainability target. So interesting use of local infrastructure. The fourth strategy called energy market options. So again, it depends a little bit on what your local capabilities are and whether or not your local utility provides you with the kinds of options that you might be able to take advantage of. But the overall idea is to work with local utilities to participate in interactive incentive programs such as demand response, or maybe take advantage of the energy spot market if you're in a deregulated environment. So, leverage whatever capabilities you have. If you've got some on-site generation capability that you are okay with kicking into action on occasion, or you've got some internal load management options where you could potentially reduce your load or shift your load to a different time. That gives you the ability to take advantage of those programs. And again, that will potentially reduce your price of electricity. So it's not necessarily lowering your demand, but it lowers your per kilowatt hour price. So, and that allows grid operators to better manage their peaks. And depending on how that load is being managed, that could, reduce the utilities' use of carbon-heavy peak generating capacity. So, cost to the data center goes down, but overall carbon footprint again could go down as a result of the interaction. So, just some examples of the kinds of things that could be done on a low spot price, energy spot price, where you might want to be purchasing from the market to charge batteries if you have additional or extra battery capacity, or a BESS system, and maximize your computational capacity. If you've got occasional load, then that's a good time to be taking it, versus the high spot price where you might want to be selling to the market to discharge batteries, run your generators, minimize your computational capacity utilization. So, shed that interruptible load when the energy market is high. And then, of course, participate in interactive programs like demand response, where the utility would request that you curtail some of your energy consumption, and just participating in that program lowers your energy cost, right? So again, if you've got a system that can help you manage that, you can start to participate in these kinds of programs. So again, it requires certain things to exploit, like on-site generation, excess energy storage, temperature headroom potentially in the data hall, or interruptible non-critical IT loads. ABB's energy management program or product can help you manage that by giving you access to the spot market data for energy pricing. Not just for electricity, but even for natural gas. For example, if you've got on-site CHP system, or some kind of more efficient non-sort of diesel genset generating capabilities, you can also be looking at the cost to run those as part of this program. So it can do some real-time pricing. It can do some forecasting based on past events or past similar scenarios, weather forecasting, load forecasting, etc., to help you drive the activities that you want to take within your data center. So, looking at what the options would be for shifting, for shedding, for turning things on or off. So the first four scenarios I described really focus on the facility and cooling and power consumption, largely around in the cooling domain. And then the question becomes, well, what happens when you fully addressed all of the potential inefficiencies in cooling? Where do you go next for additional energy reduction. So, the theoretical 1.0 PUE, does that mean that you're running at perfect efficiency? Well, it doesn't really, because the IT infrastructure is also kind of inefficient, depending on how it's loaded. So, most servers, even when they run zero load, are still consuming a significant amount of power. And there is a sweet spot on most servers where they are the loading is sort of running at optimal energy efficiency, and if you're outside of that sweet spot, there is some savings to be had. So by having the fully integrated IT and facility control systems, you could potentially start to address those energy efficiencies as well. And that concept of the integrated IT and facility is coming. I mean, it's being driven by a number of market forces. Energy consumption obviously is always something that's front of mind. But even you look at the way that data centers are now being built out, where you have the proliferation of the small sort of lights out edge data centers, which could run with highly dynamic loads, right? So, a lot of talk about IoT and 5G, and what do we do with all of the telemetry coming from smart cars, self-driving cars, things like this. It's gonna put a lot of additional requirements on building data centers, but that load is not necessarily consistent. I mean, you're not going to get a lot of telemetry from self-driving cars in the middle of the night. So does that mean that these data centers will just continue to hum along with zero load? That seems unlikely. And another trend is a move towards less robust data centers and more sort of data center as a service concepts, where you don't necessarily expect that a data center is going to run with 5 nines, but you've got ways to manage occasional outages by, for example, shifting software loads around. It doesn't work for everybody's environment, but some environments it does. So those are kind of driving this sort of combined IT and facility control system philosophy, which some have called the cyber physical control, which is total integration of facility and IT controls. So the goals would be control, monitor, and optimize the data center as a single system, managing all the elements that impact operations, including cooling and IT load allocation. And the benefits would be a fully optimized data center for energy and performance, and ultimately increased reliability. So again, energy goes down, carbon footprint improves, cost improves. So, if you take a very sort of simplistic, high-level overview of what that might look like, the facility control is still there, managing the cooling and the power infrastructure. And then you've got your, IT management, which is allocating resources, directing jobs to servers, etc. Right now, these things work completely independently. But by coupling the facility control and the IT resource management, now you have a whole lot of new options about how to manage that entire infrastructure. Where the facility control can look at even things like weather data, local energy pricing. It can provide that information to the IT resource management, and then potentially provide feedback for the way that servers are being loaded to address some of the other issues I said before. So, if you're noticing that there are hot spots or cold spots within the data center, perhaps the IT resource management could shift some of the load around to provide an environment where cooling can be run optimally, or even potentially shut stuff off if the load is not there, and adjust the cooling system accordingly. And all of that can be managed across multiple data centers. So if you have something sort of coordinating the whole data center fleet, then load could potentially be moving from data center to data center. And that's so that local facility control and IT resource management working together to consolidate the IT load for maximum server efficiency. It can focus the cooling load on consolidated servers. It can adjust the IT load as necessary, and as I said, it can use other external factors like weather and energy pricing to further inform the way that IT resource management is handled. So, I looked around to see examples of this kind of thing. One example that came out, this was actually a couple of years ago, but Facebook implemented a project called AutoScale, where they took an energy-centric or a power consumption-centric view of how their servers were being loaded and tried to optimize them into keeping the servers running as close to possible at their efficiency sweet spots and putting the unused servers into idle mode. And over the course of the day, obviously when they were at a very high loads, then the difference between the base and the scaled systems were not that high, but over the course of the day they actually saw 10 to 15% power savings, which was significant. And that was not even powering down inactive servers. If they had powered them down, they would have seen even higher servers. Other examples that have been discussed, I wasn't able to find any particular examples of this, but I'm certain that they're coming, which is this sort of follow the moon, follow the price of energy concept, where load is actually moved to the data center running in the cheapest spot market zone, which is typically wherever it's nighttime. So this would require a data center to be able to manage its load using information like spot market pricing. And obviously in that case, you have to have data centers in multiple markets, but managing it in this way could definitely generate some significant savings. Other examples include power capping, where you're dynamically adjusting the performance of servers. On a moderately loaded system, power capping can potentially significantly decrease the power consumption, especially for those servers that are not running in the sweet spot. So you're not necessarily impacting the performance, but you are taking down the power consumption. Time shifting, so running non-critical loads when cost of power is lower. And then demand response. I mean, we talked before about potentially taking advantage of energy market programs, but having complete control over both your facility and your IT gives you more room to play. For example, if you get a curtailment request or something, because now you could potentially be automatically shifting loads. You could potentially be shutting down non-critical load. You could use power capping, etc. If you're looking at weather forecasting, you can even anticipate when some of these curtailment requests could come and prepare for them in advance. So just a real quick wrap up with some of the key takeaways. Having a comprehensive overview of data center operational data is the critical starting point for sustainability improvements. If you can't measure it, you cannot improve it. So said the old guy in the picture. Simply knowing the data center operations knowing the data opens many possible avenues of improvement. So that's the open loop concept. Closing the loop on data center control can drive sustainability benefits on an ongoing and automated way. Installing a fully unified data center automation system at construction time is a cost-effective way to prepare for future sustainability initiatives. You need to put controls in anyways. They don't have to be done in siloed ways. You can do a unified system. You'll actually save costs by doing it that way, and it prepares you for some of the other options that I just described. And maybe this is just my opinion, but the future of the data center is unified and optimized. Okay, just for the sake of further reading, I collected a bunch of the articles, publicly available research and white papers, etc., that I used to put together these slides. So when you get the presentation, you can click the link and read up on some of this stuff. There's some really good, interesting material out there. And you can always visit our website for further information. Okay, questions?
Thank you, Rich. So Rich has concluded the presentation portion. We have a couple minutes here, so we should be able to get 1 or 2 questions in. So if you'd like to ask a question, you can enter it into the Q&A section. The first question I have for you, Rich, is how many types of these automation systems has ABB deployed?
We've put in about 80 to 90 of these systems worldwide, I would say. Not all of them have, there's a varying degree of how much of that data is being integrated, but a pretty substantial number.
Yeah, it sounds like it. Thank you. Another question I have is, has ABB deployed any of the automated energy management systems?
So not in data centers yet. The energy management system has been used in a number of different types of facilities, including industrial and commercial buildings. We're still looking for our first data center implementation.
Thank you. I'll have one more question here. So does ABB have any interfaces to resource management systems, or have they done any systems like what you've described today?
So we have interfaces to a number of different systems out there. For example, we've got an integration with the Intel DCM product, which is not really a resource management system, but it lets the automation system monitor and potentially control server activities. So if you want to, for example, implement power capping, you could do that under the control of the data center automation system. But the data center automation solution has an open interface so that it can very easily be integrated with resource management systems. So you could, you've got all the building blocks to put together a system like that.
Thank you, Rich. And we have one more question before I'll close. I'm going to ask, someone would like to know, how good is this for implications of hybrid AC-DC microgrid?
So I would say if you're going to implement microgrid-based data center, or a data center as part of your microgrid solution, you need to have some kind of unified control and automation system for the data center, whether it's AC or DC. So again, the underlying technology that we use for data center automation is the same technology we've used for controlling other types of facilities within microgrids. So short answer, it's the perfect technology for microgrid integration.
Thank you, Rich. That's all the time that we have for today. So when you exit the session, you will be prompted to fill out a survey, and we would appreciate any feedback that you have on today's event. Thank you all for joining, and we hope to see you in a couple of weeks for our Service Strategies for Sustainability webinar.